Volcanoes, those awe-inspiring displays of nature's raw power, have fascinated and terrified humans for millennia. While they are obviously a destructive force, capable of wiping entire cities off the map in an instant, they are also vital to our planet's ecosystem and even our survival. Did you know that all of the oxygen in our atmosphere actually comes from volcanoes? Without them, Earth would be a very different place indeed. But in recent years, scientists have uncovered a surprising and worrying link between volcanoes and climate change. It turns out that these mighty geological formations play a much more significant role in regulating our planet's temperature than we ever imagined. From ancient super-eruptions to the smallest of lava lakes, volcanoes are constantly interacting with the atmosphere, either cooling or warming the planet depending on their location and the scale of the eruption. In fact, one theory even suggests that a series of massive eruptions thousands of years ago may have played a key role in the development of human civilization. So what exactly is the connection between volcanoes and climate change? And how do these powerful natural phenomena shape our world in ways we are only just beginning to understand? Join us as we explore the fascinating science behind volcanic eruptions and their impact on the planet. You won't believe some of the crazy ways in which volcanoes affect our everyday lives. It is well known that volcanic eruptions can have a catastrophic impact on the environment. The most famous example is the 1815 eruption of Mount Tambora in Indonesia, which is considered to be the deadliest eruption in recorded history. The eruption killed over 92,000 people and caused temperatures around the world to plummet by as much as 3 degrees Celsius. The following year, 1816, became known as the year without summer and saw widespread crop failures and famine. But not all volcanoes are created equal when it comes to their impact on the climate. In fact, some volcanoes can actually help to warm the planet. But why? To answer this question, we need to look at the composition of volcanic ash. Different types of magma contain different amounts of water vapor, carbon dioxide, and other greenhouse gases. When a volcano erupts, these gases are released into the atmosphere where they can trap heat and warm the planet. For example, in 2011, the underwater eruption of the Semalis volcano in Indonesia released an estimated 125 million tons of carbon dioxide into the atmosphere. That's equivalent to the annual emissions of 25 million cars. However, not all volcanic eruptions release large amounts of greenhouse gases. In some cases, such as with Mount Pinatubo in the Philippines, the amount of gas released is relatively small. In addition to releasing greenhouse gases, volcanic eruptions can also inject aerosols into the stratosphere. These tiny solid or liquid particles can reflect sunlight away from the planet, leading to a cooling effect. For example, the 1991 eruption of Mount Pinatubo injected an estimated 20 million tons of sulfur dioxide into the stratosphere. This led to the formation of sulfuric acid aerosols, which reflected sunlight and cooled the planet by about 0.5 degrees Celsius for several years. So whether a volcanic eruption has a warming or cooling effect on the planet depends on the type of magma involved in the eruption and the amount of greenhouse gases and aerosols released. Generally speaking, eruptions that release more greenhouse gases tend to have a warming effect, while eruptions that release more aerosols tend to have a cooling effect. But it's not just the size and location of a volcanic eruption that matters. The timing can also play a crucial role. For example, in the early 1990s, a series of large volcanic eruptions occurred in Russia, including the eruption of Mount Pinatubo. These eruptions released a large amount of sulfur dioxide into the atmosphere, which formed aerosols that reflected sunlight and led to a rapid cooling of the planet. However, by the late 1990s, the cooling effect had largely disappeared. This is because the sulfur dioxide had mostly been removed from the atmosphere by rain and other forms of precipitation. This is in contrast to the impact of Mount Pinatubo's eruption, which continued to cool the planet throughout the 1990s and into the early 2000s. So while volcanic eruptions can have a significant impact on the climate, the effect is usually short-lived. Over geological timescales, however, the impact of volcanoes on the climate is much more significant. Volcanic eruptions can have both short-term and long-term effects on the climate. Short-term effects typically last for a few years and are due to the injection of aerosols into the stratosphere. Long-term effects, on the other hand, can last for decades or even centuries and are due to changes in the composition of the atmosphere over time. For example, studies have shown that increases in volcanic activity are associated with increases in global temperatures. One study published in the journal Nature in 2012 found that periods of high volcanic activity were associated with an average temperature increase of 0.27 degrees Celsius per decade. Another study published in 2015 found that the most explosive eruptions in the past 18 million years led to an average temperature increase of 1 degree Celsius. So what is driving this relationship between volcanic activity and global temperatures? One possibility is that the greenhouse gases released during volcanic eruptions are causing the planet to warm. As mentioned earlier, different types of magma contain different amounts of greenhouse gases. And when these gases are released during an eruption, they can trap heat in the atmosphere and lead to a warming effect. However, another possibility is that the warming effect we see during periods of high volcanic activity is actually a response to the cooling effect of major eruptions. As we saw earlier, large volcanic eruptions can inject significant amounts of sulfate aerosols into the stratosphere, which reflects sunlight and lead to a cooling effect. In the years following a major eruption, the planet may experience a period of cooling. However, as the aerosols gradually disappear from the atmosphere, the planet may begin to warm. One study published in the journal Quaternary Science Reviews in 2017 investigated the relationship between volcanic activity and temperature over the past 14,000 years. The study found that periods of high volcanic activity were associated with warmer temperatures, but only after accounting for the cooling effect of large eruptions. This suggests that the warming effect we see during periods of high volcanic activity is a response to the cooling effect of major eruptions, rather than a direct effect of greenhouse gas emissions. While there is still much that we do not understand about the complex relationship between volcanoes and the climate, it is clear that these powerful natural phenomena play a significant role in shaping our planet's environment. From the massive eruption of Mount Tambora to the ongoing activity of the Yellowstone supervolcano, volcanic eruptions have both shaped and continue to shape the world we live in. And as we continue to learn more about their impact on the climate, we will undoubtedly uncover even more fascinating insights into the workings of our planet. There is also evidence to suggest that volcanic eruptions may have played a role in the development of human civilization. One theory, known as the young Dryas theory, suggests that a series of large volcanic eruptions around 13,000 years ago may have triggered a rapid drying of the climate, leading to the formation of the Sahara Desert and the development of agriculture in the Fertile Crescent region of the Middle East. This, in turn, may have laid the foundation for the rise of human civilization. However, other scientists have challenged this theory, arguing that there is no direct evidence linking volcanic eruptions to the development of agriculture. Despite the ongoing debate, the potential connection between volcanoes and the development of human civilization is an intriguing area of research that could shed new light on our species' evolutionary history. In conclusion, volcanoes are truly fascinating natural phenomena that have both shaped our planet and influenced human civilization. While they can have devastating short-term effects on local environments, their long-term impact on the climate is complex and not fully understood. As we continue to learn more about volcanoes, we will undoubtedly uncover even more fascinating insights into these powerful geological formations and their profound impact on our world. What are your thoughts on the relationship between volcanoes and climate change? Do you think that volcanic eruptions have played a significant role in shaping our planet's environment and our species' evolutionary history? Let us know in the comments below. If you enjoyed this video, don't forget to like and subscribe for more informative content. Thank you for watching.